Rotational inertia. What is rotational inertia? Well, it's essentially the principle that the farther away a mass is from the axis of rotation, the more force is required to rotate the object. And it's broken down into an equation. But it's better illustrated by the following real-world example. Here, Austen has a pretty heavy book bag, and what he's going to do is he's going to try to lift that, but he's going to lift it and just curl it from the elbow. So it mimics curls that you would have in a normal exercise. And as you can see, it's not too terribly hard to lift the bag. Now in this example, Austen's going to flip his axis of rotation from his forearm, or rather his elbow, to his shoulder, therefore increasing the lever length on his arm. And you'll notice that it's much more difficult to lift the bag because the axis of rotation is greater, so the force is also required is also greater. So getting back to the physics of it, there's a correlation between the radius and the moment of the inertia. And the longer the radius, the higher the moment of that inertia is going to be. So essentially, if a object has a larger moment, it's more likely to resist change. Essentially what that means, in this case scenario, is increasing the arm length on the axis of rotation, like we did with Austen's arm, means that it's harder to move the bag. And that's why you saw him struggle a little bit more when we moved the axis of rotation from his forearm to his shoulder. Here we get an example that's a similar illustration. Essentially, you have two balls of the same mass, but their radius of rotation is significantly different. One's at 6 meters and one's at 2 meters. And for this reason, ball 1 has a greater moment of inertia, and therefore it's harder to move. And that's all we have for you on rotational inertia, so thank you for watching.